Hello everyone, welcome to the ISRI Student Conference. Today our guest speaker is Dr. Ali Daneshy. The topic of the day will be oil and gas production and ISRI, alignment of objectives. Ali Daneshy is a president of Daneshy Consultants. He was a director of petroleum engineering at the University of Houston between 2004 and 2007. He was a vice president of integrated technology products at Halliburton Energy Services in Houston, Texas between 1996-1998. He is holding a degree in mining engineering from University of Tehran, and he's also holding an MSc degree in mineral engineering, rock mechanics from University of Minnesota. And he's also holding a PhD degree in mining engineering, rock mechanics from University of Missouri-Rolla. He is a co-editor-in-chief and publisher of Hydraulic Fracturing Journal, a quarterly publication entirely dedicated to various technical and operational aspects of hydraulic fracturing. He has over 75 technical publications in various areas of oil and gas completions and production, mostly covering hydraulic fracturing and associated technologies, and over 15 publications in various areas of technology and management and engineering creativity. He was also a member of SBE Legion of Honor in 2018. He was also SBE Director between 2005 and 2008. Now it's time to hear dear Dr. Ali Daneshy. Dr. Daneshy, we are glad to be here today.
Thank you very much for that introduction. So let's start by reviewing the background. E3 objectives are in everyone's best interest and need our active support. Look, protection of environment and improving the environment is a general public interest. And I think we all need to support it. Oil and gas industry plays a very critical role in providing the energy needed for our comfort and growth. And worldwide, there is a continuous increasing demand by all the people in this world for more comfortable life. We like to have access to technology, and we want to have better and more user-friendly products. And also keep in mind that in addition to these increasing demands for a better life, the world population is also increasing, which means the volume of demand is gradually increasing as the world population increases. Now, let's look at the role of engineers. Reducing the damage to the environment and its protection are the social responsibility of every citizen, especially the engineers, because we have the knowledge and tools for making significant contributions to the improvement of and protection of the life and the environment. So as engineers, we have got an added responsibility to be protective of the social needs of the environment and be contributing to its improvement. So let's look at the role of oil and gas for world energy supply. Worldwide, our daily consumption of oil is around 100 million barrels per day. Some of the main applications of oil and gas, you all know this, but I think it's good for us to review this just quickly. For transportation, we all drive cars and they run on gasoline. Heating, electricity generation, for farming applications, road construction, building roads, development of chemicals, plastics, synthetic materials. We use oil and gas, hydrocarbon materials for all of these different purposes. Now, together with the positive benefits of these, we also have got some negative side effects from these. In addition to these benefits, consumption of oil and gas has these negative side effects. Air pollution, you all know about that. Water pollution, climate change, the changing, everybody's talking about climate change and heating, thermal pollution, which is again heating of the environment and the everything getting warmer, solid waste that is generated as a result of our oil and gas production operations. And so even with these side effects, oil and gas is still the best option for generating our energy needs at the present time. So while we recognize the negative side effects of these, the consumption of oil and gas, I think everybody needs to realize that this is still our best alternative at the present time with our capabilities at the present time. So what is our way forward? Given our strong need for consumption of oil and gas, what are our best strategy to minimize the negative side effects of the production of the oil and gas without making onerous changes in our daily lives? And the answer to that is technology. Using technology, we need to focus on development of more efficient tools and techniques for production of oil and gas and also for consumption of oil and gas. Essentially, our savior for the future is going to be technology, development of it, and application of it. More efficient oil and gas production will contribute substantially to improvement of the environment. Oil and gas industry must continuously strive to improve the efficiency of its production techniques and the processes that we use for its production. Some of the very effective recent technologies for increasing the efficiency of oil and gas production are the ones that you all are familiar with, but I'll just go over them very quickly. Drilling long horizontal wells, often more than a couple of miles long, inducing large number of hydraulic fractures in each well, as I will describe to you in just a minute. The result has been daily production of several thousand barrels of very light crude from drilled wells in nano-Darcy permeability formations, which were previously non-productive. These are in shale formations that were previously non-productive. Development of use and these technologies has resulted in substantial reduction of the environmental impact of their production per barrel of produced oil. Let's get into this a little bit more. US daily oil production is around 7.4 million barrels. A vertical well drilled and fractured in these formations would have produced just a few tens of barrels of oil each day. So you can imagine, and many of these vertical wells needed to be drilled to the depth of 10,000 feet. And let's consider, just as engineers, we can do a very quick calculation. If each well is producing something 30 barrels of oil per day, and we want to produce 7.4 million barrels per day, how many wells do we need to drill? Just think about it. Divide 7.4 million by 20 or 30 and see how many you end up with. Number of well sites, number of working days to drill all these wells, required volume of water for drilling all these wells, volume of release cuttings and how we're going to dispose them. Again, something to be thinking about. And the cost of the produced oil. If we have to drill so many wells and treat them to be able to produce the required volume of oil and gas in order for us to live our life the way we are. More efficient production of oil and gas has been contributing to improvement of the process. So what are we doing? We drill pad drilling, we drill multiple wells at the same time. First of all, we drill horizontal wells, and these horizontal wells extend sometimes more than 2 miles. And in each of these horizontal wells, we create several hundred fractures. And that in itself has resulted in production of, let's say, 1,500 to 2,000 barrels of oil per day from a single well, as opposed to drilling 20, 30 barrels of oil from each well that would require a much larger number of wells. Now, in addition to that, the other technology improvements that we have introduced are pad drilling, which means we drill multiple wells at the same time, which brings the efficiency of the operations, well site, equipment, and everything else. Pad fracturing, fracture multiple wells one after the other one consecutively, so that when the equipment moves on location, instead of fracturing one well, moving off and coming back again, we fracture multiple wells one after the other one. the next step in this process has been simul-fracturing, which means fracture two wells at the same time with the same equipment. As you can see, each one of these has created a working environment that has reduced substantially the environmental impact of our drilling and fracturing operations. And so development and application, every one of these technology advances has resulted in a significant reduction in the environmental impact of oil and gas production. So next changes in drilling and fracturing operations, the next changes that we can make will be how long a horizontal well do we really need to have? At the present time, the length is around 2 miles. Is this the optimum length? What is the optimum spacing between these wells? Right now, these wells are somewhere in the order of 800 to 1,000 to 1,200 feet apart. Is this an optimal spacing between them? How many fractures do we need to have in these horizontal wells in order to get the best production? And the best production, I mean, in terms of the volume of production as well as this environmental impact. How big a fracture do we need to create? At the present time, in some of these wells, we drill somewhere in the order of, we inject somewhere in the order of a few million barrels of water. We pump somewhere 10 to 20 million pounds of sand in each one of these wells. Is the volume of materials sufficient? Is this optimum for getting the production that we need, getting the desired number of fractures and so on? These are all technical questions that need to be addressed as we move forward in order to improve the efficiency of our operations for the production of oil and gas. So our challenge is oil and gas reservoirs are located at great depth in very heterogeneous and inaccessible formations, and often locations already used for other purposes at the surface. These are sometimes in farms, in pastures, and so on. And so what we are looking at is sharing a location with other applications. Drilling, fracturing, and production operations change the engineering properties of the reservoir and further complicate the problem that we're trying to solve. What do we need to know in order to improve the efficiency of our fracturing operations? And one new technology that has been introduced just in the last 5 to 10 years has been Frac-Driven Interactions. And the detection of analysis of pressure changes in an offset well caused by each stage of fracturing in a new well. And when we do this, this has opened a very promising gateway to the next generation of fracturing treatments. And we are able to see what kind of fractures are already existing in the formation, and then what are we doing as a result of our fracturing operations. And if we could real-time detection and analysis of this data can provide the necessary information for us to go ahead and substantially improve the efficiency of what we are doing in terms of fracturing these wells. So my last word are these. There are three kinds of people: the few who make things happen, the many who watch things happen, and those who have no idea what has happened. Just when you think something can't be done, somebody goes ahead and does it. As engineers, it is our responsibility to improve and enhance the efficiency of our operations. And if we don't do it, nobody else is going to do it. It is our responsibility to do that. And so with that, let's get to work. Thank you very much. That's the end of my presentation. Now I'll be happy to answer questions.
Thank you very much for this extremely informative speech. Excuse me. Yeah. So we appreciate your time. Now it's time for the question of our audience. The first question is, what's the location of shale gas from renewable energies and hydrogen?
I couldn't. Can you repeat that? I couldn't hear you.
Sure. What is the location of shale gas from renewable energies and hydrogen?
Okay, look, the renewable energy and hydrogen, these are things that are going to continue to improve and get better, and we need them. And as long as we can produce them, that's a good thing to happen. I think we all need to support that. And by the way, let's don't forget that those things also come as a result of engineering work. But at the same time, the rate of growth is insufficient to meet the needs. At the present time, the projection is that we're going to need at least 70, 80 million barrels of oil per day for the next 20 to 30 years. And these other sources of energy, the renewables, hydrogen, and all the rest of them, they basically, at the present time, about all they are able to do is to take care of the expansion of the need, not reduction of the need for oil and gas. In other words, as the need for energy increases, these other technologies are filling the gap. But the need for oil and gas is continuously moving ahead. And if anything, there is the best we can project for the next 20 to 30 years is to just not increase the production of oil and gas, but to take care of what we need with the existing production and let the other technologies fill the added need for energy.
Thank you very much for answering our question. The second question is, what is the role nuclear well logging techniques in the oil and gas industry?
Nuclear energy is going to be an important part of the energy supply in the future. So there is no question that we need to have nuclear energy. Let's also don't forget that nuclear energy has got its own technical challenges, but nevertheless, technology and is going to make those applications, nuclear energy, safer for us to go ahead and use it. But we are doing the best we can with nuclear energy at the present time, and even that at best can supply some of the expanded energy need, but we don't anticipate that this time that is going to fill the energy needs for the next 20, 30 years.
Thank you very much.
One other thing to also keep in mind is that the nuclear energy is in many countries, nuclear energy, the application of nuclear energies has also got limitations imposed by law, by local laws. So while we try to improve the effectiveness and safety of nuclear energy, we also need to be aware of those other aspects of it.
Thank you very much. The next question is, does the thermal energy applicable everywhere?
Which energy you said?
Thermal energy.
Oh, thermal energy depends on what the source of it is. If you're talking about solar energy, the heating and so on, of course, it can be used. It is very good to have. And but again, that has also got its limitation. You see, all of these, in theory, they sound very good and attractive, but we need to have the facilities, the equipment, the processes, the people, and the locations to go ahead and develop these sources of energy. And until such time when these technologies are widespread and applicable everywhere, they are not going to fill our total need, and we're going to have to continue to rely on oil and gas, which exists and we have it and we are producing it in order to take care of the needed energy, and let these other sources of energy basically take care of the additional needs. And of course, look, if we can reduce the need for oil and gas through development of these other technologies, I think that's a very good thing. There is no argument against that at all. But at this time, in my view, we cannot afford to cut back on production of oil and gas in the hope that we will develop the other ones. the better approach would be to let the other ones be developed and then try to fill in the additional need with oil and gas.
Thank you very much. Another question is, why is oil and gas is the best option for generating our energy despite the negative side effects? And is it the best option in every region or location?
The reason it is because we have got the processes, the equipment, the know-how as to how to use it. You see, just about everywhere you go, there are oil and gas wells. We know how to produce it. When it comes to the surface, we know how to store it. We know how to pipelines move it from one place to the other place so it is available. There is a lot of infrastructure in place to make the oil and gas, which is produced from certain locations, not everywhere, but make that oil and locally produced oil and gas available worldwide for people all over to use. And so there are, for example, if you take a look at Western Europe has very little oil and gas production. And the reason Western Europe is taking care of its energy needs is because of pipelines which are already in existence. They have been built and put in place. And those facilities have taken a long time to be developed. And so that's the reason oil and gas is our main source, because the facilities and the capabilities for its production and distribution and application is more or less globally available everywhere. But also keep in mind, if we want to use the other energy sources, the same facilities need to be developed before we can cut on oil and gas production. And those other facilities are not as developed as they are for oil and gas.
Thanks a lot. Our another question is, there are environmental issues about the considerable increase in conducting hydraulic fracturing operations. Is there a less contaminated approach in reducing hydraulic fracturing operations?
That's the challenge that we all are facing as engineers. That's the challenge that I'm raising for everybody. Look, we have been improving the efficiency of oil and hydraulic fracturing for oil and gas production. This is an ongoing engineering effort. It has been going on for the last 50 years, and it will continue to move on. So absolutely, we need to do what we can in order to improve the efficiency of these operations. But also keep in mind that what we are doing at the present time is about the best we could do with our present capabilities and knowledge. And that's the challenge to the young engineers, to try to develop better ways and easier ways of producing oil and gas and hydraulic fracturing in order to reduce its environmental impact. There is no question that such developments are needed and they should be coming forward.
Thanks a lot. How can a reservoir engineer or production engineer contribute to reduce the environmental impact of the petroleum industry?
By producing more efficiently and more effectively. If we can produce the volume of oil that we need more effectively and more efficiently, then we will not need the facilities and the systems that we have right now. And if we can improve the efficiency of our operations, then that is going to reduce its environmental impact. And that will be a major contribution. And that is the challenge to our young engineers, to find better ways of producing the oil and gas that we need. And better ways, in fact, means less environmental impact. Yes.
Thank you very much. As we know, hydrogen is the future oil. What does this mean for the oil and gas industry?
Hydrogen, first of all, let's don't forget that gas that we produce from reservoirs is a very good source for hydrogen. So hydrogen is not something that you go and produce from someplace. You have to have a source for hydrogen itself. But as we develop better ways and more efficient ways of generating hydrogen, of course, then it will reduce the need for oil and gas, and then will improve the environmental conditions under which we live, and it will be good for everyone. So I think that's something that is good. It needs to be done, and it's part of the future.
Thank you very much. And what are the latest technologies or techniques that you know that are being developed to improve efficiency and reduce carbon footprint?
Oh, that's something that's going on all the time. And part of that, of course, is more efficient consumption of oil and gas. Let me give you a very simple thing that all of us are faced with. We have been driving cars for quite a long time. Consider the automobiles that we were driving 50 years ago and the cars that we are driving today. How efficiently are our cars running now as opposed to how they used to? The exhaust fumes, the gas consumption, the type of oil and gas that we used to use in these cars, the manufacture of the cars themselves. When you think about the process, someone like me, I've been driving a car for 50 years. The car that I drove 50 years ago wouldn't exist today because it was very inefficient. And as we improve the efficiency of operations and improved our knowledge, gradually the cars that we are driving are getting better and more efficient, not only in using less energy, but also burning the energy more efficiently with less impact on the environment. So every place where we are generating energy, generating power, every one of them can become better, more efficient, and in doing that, we improve the quality of the environment.
Thanks
and by the way, one side effect of that is it reduces the need for increasing the oil and gas production.
Thanks a lot. Amazing. So also, another question is, how feasible is carbon capture technology?
I'm not an expert on that subject, and I cannot really tell you a whole lot about that. So I think it's better if somebody who has better knowledge of carbon capture discuss that. As far as I know, there is activity going on in that regard, but I'm not an expert. I better leave that to somebody else.
Thanks a lot. Gas from hydrate, is it a new promising source energy for hydrocarbons?
Yes, we are finding more and more ways of using the hydrocarbon, different types of hydrocarbon that come out of the formations. And as we increase our knowledge of these products, and we develop the techniques and equipment and facilities for their application, of course, that's going to be a positive thing and something that can be helping us. One of the things, for example, that is going on, and I want to bring to everyone's attention. You see, at the present time, with oil and gas production, there is a certain amount of methane and hydrocarbon which is vented to the atmosphere. Just reducing that volume and capturing that and putting it to use will have a good impact on the environment and will increase the efficiency of what we're trying to do. So every little step is going to be useful, and it needs something that deserves our attention. Yes.
Amazing. Do hydraulic fracturing operations help in increasing a field production without affecting its reserve? In other words, don't reduce its age by increasing significantly the production?
Of course, hydraulic fracturing is a tool for increasing the production. Hydraulic fracturing, as I said, if it wasn't for hydraulic fracturing, we will need a lot more wells and a lot extensive operations in order to produce the oil and gas that we need for our daily life. But like any other technology, it has been undergoing changes. It's gradually getting better and better. And I have no doubt that within the next 5, 10, 15 years, we'll develop better techniques and better systems for doing better frac jobs. And that means producing more volume of oil and gas per well, which reduces the number of wells and reduces the footprint of these operations on the environment. So this is an ongoing process. It is continuously getting better, and I have no doubt that it will be even better 5, 10, 15 years from now. The younger generation are very smart. Let's see what kind of thoughts and ideas they come up with to improve on what the old timers like me have been able to do so far.
Thank you. The next question is, if you are in front of taking the opportunity of exploration of your huge reserve of shale gas for some economic reasons, despite losing the same huge aquifer that you have or taking the risk of losing it, what will you do as a petroleum engineer?
Look, the reason we are producing from shale reservoirs is because that's the reservoir we have. And, you know, for example, in Saudi Arabia, they don't need to produce from shale reservoirs because they have got good reservoirs with much more prolific reservoirs. As time goes on and we produce and exhaust our existing reservoirs, we have to depend on less productive formations and less productive reservoirs. And so the reason we are using shale is because that's what we have. If we had another alternative which was better than shale, we wouldn't be developing shale. And for many years, we didn't work on shale because we didn't need it. But at the present time in this country, it is one of our few options, and that's why we are producing it.
Thank you very much. That was the end of our question. Thank you very much for answering our question, despite it was a lot, with a special attention. We really appreciate your time. Dr. Soliman, are you here?
Yeah, I am.
Do you mind joining us?
Well, Mohammed, I'm sure you can add quite a bit to what I said. You're a frac expert yourself, so please go ahead and add to other things that come to your mind that I didn't.
I want to ask your opinion of, one of the issues in hydraulic fracturing is the large amount of water that needed to fracture wells, especially in case of shale, when you have a mile long or mile long is not very long anymore, a couple of miles long horizontal well, and you create maybe 100, at least the plan is to create more than 100 fractures. That requires
400 fractures. The more recent ones are 400 fractures.
Right. We started in fracturing horizontal wells many years ago. We're just creating maybe 4, 5, 6 fractures in a well. Wells were shorter. Now they are a lot longer and more than 100 fractures. That requires millions of gallons of water.
Correct.
So there is a lot of push to go into waterless fracturing. What do you think about that?
Actually, that's actually one of the items that I was discussing. Let me go up to that. This is the challenges that we're faced with are related to increasing the efficiency, which includes how long a well do we need to have. We are drilling them 2 miles right now because that's the ongoing practice, and people have learned how to do that. But how long these wells need to be to get more efficient operations? What's the spacing between these wells? We are saying, right now it's somewhere around 1,000 feet, 800 to 1,300 feet. Is that an optimum spacing? Number of location of fractures in each well. Right now we are putting these fractures every 20, 30 feet apart. Is this an optimum number? size of each fracture. And the materials, in some of these horizontal wells, we are pumping 10, 20 million gallons of water. Is that an efficient use of the water? And so that's the challenge that we are faced with. And do we really need to have? Can we improve on the systems as they exist and as we are practicing? And my response to that is, I'll give you my very frank response. I think we are a little bit overdoing it. We should be able to produce the same volume of oil and gas with a smaller footprint in terms of materials, in terms of equipment, in terms of number of wells, and so on, number of fractures. And that is something that deserves our attention, and it should be the focus of the ongoing improvements that we are trying to make. Your point is very correct, yes.
Well, another thing when I was listening to your talk about, there's question about nuclear energy, which in my opinion, I think is very important, but it has significant issues. The depleted uranium, once you finish with it, the depleted uranium rods will have to be stored somewhere, and it can be active for thousands of years. So nobody in United States, no state wants to take on storing this material. At one time, there was in Nevada, there was, I can't remember the site, but anyway, they were trying to store it there in a mountain. And right now, this is a big issue. What do you think about that?
You're absolutely correct. That is an issue. And actually, one of the techniques that has been discussed for storing the wasted nuclear material is to drill wells, fracture them, and put the material in fractures. That's one of the processes that has been discussed. And just as we try to improve the efficiency of our fracturing operations, I think the people who work with nuclear energy also need to consider ways of improving the efficiency of their operations. And in many countries, you cannot use nuclear energy at the present time because of the regulatory issues. So it is something that sounds promising, but needs further investigation and further analysis before it becomes more applicable. I personally do not think that in the long run, nuclear energy is going to be the answer. Other sources of energy that that were discussed earlier, thermal, the sunrise and these other sources are more friendly alternatives to nuclear energy.
Well, unless one goes into or find a way to do cold fusion, it has a bad name. The cold fusion was discussed many years ago, and it proved to be almost not a hoax, but it was, the experiments could not be repeated. But there is some discussion about fusion without basically at not room temperature, but doing it in a smaller scale. If this happens, you have unlimited, infinite amount of energy. Although taking that energy back into cars, for example, is not going to be an easy thing to do.
Yes, and these sources of, you're absolutely correct. These sources of energy are being reviewed, are being developed. There are investigators who work on them. And but meanwhile, while these are going on, we still need to continue with our lives. And at the present time, our number one source of energy for what we are doing is oil and gas. And as these other technologies develop and they become available, then of course the need for oil and gas will decrease. But again, I repeat something which is very important. As the world population is increasing first, and second, as people's demand for better life is increasing, that means that the need for energy is going to go up. So even if we can maintain the consumption of oil and gas at the present level and try to make up for the added need through other sources, that is still a major improvement that needs to be recognized.
Absolutely. Absolutely. There was another question, two more questions. One about hydrogen. There is, I wish Dr. Farouk Ali was with us, was attending. There is some calculation about hydrogen and creating hydrogen out of methane.
Right. That's the source of it, yes.
The only problem with in the process, you also create CO2.
Right. You produce CO2 and you also need a lot of energy to make that conversion.
Exactly. I was going to say this exactly the same thing. You require a lot of energy to do it. Whether this is going to be economical process, I have some doubt in myself. I have not done the calculations, but these calculations need to be done to see how much energy it takes you to do it, and then how much energy it will take to store CO2, because you can't release it to the atmosphere.
Yeah, and let's keep also one other thing in mind, and that is that the oil and gas that we use is not only used for energy, but it is used for a number of other things. It is used, for example, in plastics. Plastics, the raw material for plastics is oil and gas, synthetic materials, chemicals that we use. So the need for oil and gas is going to continue for a long time to come. What we are looking at is not eliminating the need, but to try to keep it to a minimum.
Yeah, what you mentioned, that for the next long time, actually, for a long time, we will need to produce oil for energy as well as for other byproducts.
Right. This is one of the things that sometimes makes me a little bit unhappy, is this focus on fracking and the talk about banning fracking and all of that without fully understanding the consequences of that. I think what we need to look at is efficient production of oil and gas, and not focus on any particular technology as being unfriendly or being harmful or anything like that. In order for us to get the energy needs, the oil and gas needs of the present time, we really have to depend on fracturing. There is no alternative for that.
There is in chat, there was a comment about nuclear waste management deep in geological repositories. In one way, he's saying in one way we can manage this waste. Nuclear waste are buried hundreds of kilometers deep. I don't know about hundreds of kilometers, but it can be. That's what in Yucca Mountain, the idea was to bury or to store nuclear waste. However, right now I know in the United States, no state wants to do that in their territory, and that's what makes it even more difficult. If you look at chat,
I'd like to add to that I think one of the challenging misconceptions is that many people view nuclear radioactivity as almost a magical source of harm, and anything but of course, like any other toxin or hazard, it's the concentration or intensity that really makes it dangerous. And so, frankly, personally, I've always had some reservations about shipping all of our nuclear waste to one concentrated site, rather than finding many sites. I understand the desire to be able to supervise one site, but it is when we concentrate a hazard that it really becomes dangerous, in my opinion.
Yeah, besides those nuclear waste will be there for many, many, many years. You know, the half-life is thousands of years. So it is, practically, go ahead.
One area in which I have been, active for the last 4 or 5 years has been geothermal energy. And do you know, the way we are talking about producing geothermal energy is to drill wells, horizontal wells, fracturing them and circulating cold water through the hot formation in order to heat up the water to bring it to the surface and use it.
Right.
So the technology need is there, and it is a useful technology. The question is improving the efficiency of its use.
We at University of Houston will propose the different way. Rather than hydraulic fractured wells, we stimulated the wells using a waterless technique. It does create short fractures in the 10, 20, 30 feet long, multiple of them. So we have a different take on it. We're trying to make it.
And that's what makes progress. You take that approach, somebody else takes a different approach, and as we put them into practice, we find which one works better. And sometimes we join these together, marry them together, and come up with a hybrid system.
Right.
That makes it even better.
Yeah, I totally agree. About CO2, CCUS, capturing carbon out of, or CO2 out of the environment, out of the air, basically. That's a difficult process, and it's expensive process.
And it takes a lot of energy to do that.
Right. Yeah, it takes a lot of. I tend to, I agree with you and with the previous speaker that said that we'll need oil for many more years to come. It's not, you can't, I can't remember who mentioned that if you stop, whether it was you, Ali, if you stop production, I think you said that. If you stop production of oil for a few days, it would be a disaster everywhere. Yes. You mentioned that, I think.
Yes, and let me just point out to something. You see, if we reduce the production of oil and gas, the need is not going to go away. So what will happen? The price will go up. And as the price goes up, our standard of living will go down. Because we cannot, instead of using our financial resources for food and medicine and other things, we use it for buying oil and gas that makes the other aspects of life less friendly. So it is a balance between these things that is important, and I think we need to keep that in mind.
Okay, very good. Thank you, Ali, so much. That was extremely interesting. And thanks.
Thank you for the invitation. Thank you, and I enjoyed this. And hopefully, we'll all work together. This is a challenge for the young generation. It is up to you to improve on what we have been trying to do. And I have no doubt that with the smart brains that are out there, you are going to make substantial improvements to what we have been able to do. And that's the challenge to you.
Thank you very much. It was an honor to be here today. And also, dear attendees, you can rewatch this session from PyPetra's YouTube channel. Thank you everyone so much and stay safe.